Hello, Mr. Sunderland's advanced geometry students. How are you guys doing? I hope you're doing well, hanging in there. As you probably know by now, school is going to end about a week earlier. So, that being said, the light's kind of at the end of the tunnel here, my friends. I think that's about 3 weeks from Friday, is what that means. So, just keep your heads down and we're going to get through this. What I want to work on you, what I want to work with this week. Let me try one more time. What I want to work on this week with you, there we go. I think I said that right. Is the law of cosines, okay? That's something new. We did the law of sines last week. It's kind of a big topic, so I want to review or just give you a couple practice problems there to go over with you at the beginning of the lesson. Okay, so we're going to review the law of sines, and we are going to learn how and when to apply the law of cosines. So let's get started here. Here I've got a triangle where I know some angles, I know some sides. Go ahead and pause this when you're ready to go about solving for x using the law of sines. Okay. When we look at this problem, we may notice, well, shoot, there's not an angle across from x. However, if we do some triangle sum theorem, these two angles give me 144, telling me my third angle has to be 36 degrees for them to all add up to 180 degrees. So we plug our known sides and angles into the law of sines. Now the left I don't really have a choice with. I'm solving for x, so I'm going to put x in the top of my proportion. That's definitely the smoothest way to do it. So we'll go x over sine of the angle across from x. However, you do have some options on the right side of this proportion here. I just chose to use 12 and sine 41, so I'm going to follow through that way. If you chose to use 17.8 and 103, you'll get just about the same answer as we will. Okay, but to solve this proportion that I have written now, just one move gets x by itself, and that's multiplying both sides by sine 36. So I get x equals 12 sine 36 over sine of 41. Okay, and we can just type that right into our calculators, just like so. And I get that x is 10.75. Our units are meters, so make sure to add meters to your final answer there. Hopefully, we're feeling good about that one. Let's try another one here. This will be one where we're solving for angle x up top. Okay, go ahead and pause when you're ready to go about solving this. Of course, you hopefully know, feel free to pause at any time. You shouldn't be watching this lesson in real time. You can stop it, rewind it, whatever, watch it 4 times if you need to. Okay, that's what this is for. It's for you to have enough time to make sure you understand the lesson. You don't just need to know everything after watching the lesson once. Okay, but go ahead and pause when you're ready. Solve for angle x. All right, so because I'm solving for an angle, I'm going to put the sines on the top of my proportion, okay, and the sides on the bottom of the proportion. It's just going to be a little bit smoother when we're solving for x that way. So sine of x over the side across from x equals sine of 67 degrees over 13. Now I can't use the 13.1 because I don't know the angle across the 13.1. So it's kind of a decoy there. All right. But to get sine of x by itself, in one step I can just multiply both sides by 10. And then to go from sine of x to x, just like we were doing with right triangle, sine, cosine, and tangent, you're going to do the inverse sine of that whole monster there, 10 sine 67 over 13. Okay? As some of you have noticed, it's important on the calculator, depending on which type of calculator you have, the order in which you are putting all that in. Okay? Some calculators, even the one that I have at home and the one that I'll show right here, I need to use a lot more parentheses on my calculator at home. But we should be able, typing in sine inverse 10 sine 67 over 13, we should end up with 45.08 degrees. Um, if you're having some calculator issues, please shoot me an email or attend our Zoom session at the end of the week on Thursday. All right, so I get to a problem like this one, and I'm a little bit stuck. Because if I look at any set of sides or angles, I don't have at least one pair where I know the side and the angle across from them, which means I can't use the law of sines. I can't use SOHCAHTOA because it's not a right triangle. So that's why we have, oops, the law of cosines. Okay, now just like the law of sines looked a little bit crazy when I wrote the extended proportion up there, this is another one that looks a little bit nuts. We don't use all three of these. This is simply a way to show how all the sides and the angles relate to each other. Okay, after you practice this a few times, you'll actually realize that the equation is actually pretty easy to remember. Okay, but put that down in your notes, and once we start putting it into practice, it should make a lot more sense. Okay, I hope you're not too intimidated by the way it looks right now. So let's go back to that example that we had before. Let's see if we could tackle this using the law of cosines. All right, so we're going to solve for side x. Typically, when you're using the law of cosines to solve for a side, you're going to have x then be the thing that's by itself on the left. So taking something like this law of cosines example here, we're going to plug in everything based on this triangle into that equation, okay? The key is if I look at cosine of A, that would make side A the side that's across from angle A. Okay, so when I plug in everything, I've got x squared equals the other two known sides squared, 10 squared and 14 squared, minus 2 times those two sides, 2 times 10 times 14, cosine of the angle across from x. And now just plugging that stuff in and figuring out what to plug in where is the tricky part. At this point, it's a one-move algebra problem. How do you go from x squared to x? You take the square root. And you can just take the square root of that entire nasty expression in one step on a calculator. If you're using a slightly less sophisticated calculator, you might have to do it in a few steps and write things down. But the actual math happening here isn't too involved. So for my final answer, I'm going to get x equals about 14.47 for my side length. I don't know if I had units in here or not. I did not. Now looking at the triangle, if I were to, the other two angles, right, have to add up to 108 degrees. Meaning if you kind of split that in half, 54, maybe one of the angles is a little more than 54 and one's a little less. My point is, given the fact that we got something bigger than 14, and the fact that A will most likely be the biggest angle in the triangle should sit well with us. It means our answer makes sense in this problem. Okay, let's try another one. Let's try another one. So, we are going to try to use a law of sines. Oh, shoot. I've got a side length of 11, but I don't know angle C. I've got a side length for A, which is 10, but I don't know angle A. I've got an angle of 41 degrees, but I don't know side B. Shoot. Well, that's why we can use the law of sines. Okay. Sorry, the law of cosines. Now let's do it. And what we're going to do here, by the way, let me go back for a second. It's telling us to solve the triangle. So that means we have to actually figure out every angle and every side. Okay, the first thing we have to start with is the side. So let's use the law of cosine similar to how we did the last one, and we'll get that side. So I'm going to say, because I don't know side B, I'm going to say B squared equals the other two sides squared minus 2 times those sides cosine of angle B. Plug in everything that you've got. Okay. And in one step, I can get B by taking the square root of that whole thing. Now, if I've got side lengths of 10 and 11 that are pretty similar to each other, and an angle of 41 degrees, well, I should be expecting side B to definitely be the shortest side. And when we take the square root of both of those, I don't know if I showed that on the calculator with this one or not, but 7.41 should sit well with us. That feels like a pretty good length. I should expect it to be less than 10 and 11. Okay, so now that we've got all three sides of the triangle and one of the angles, we've got enough information to use the law of sines. So I'll let you pause it. See if you can use the law of sines to solve for either angle A or angle C. Doesn't matter which one you solve for first, because once we get one of them, we can use triangle sum theorem to get the other. Let's go ahead and pause, see if you can use the inverse law of sines to get one of those angles. All right, so because I'm solving for an angle, this is when I like to put sine on the top and the side lengths on the bottom. So I'm just going to arbitrarily choose to solve for angle A first. So I'm going to say sine of A over the side across from it, 10, equals sine of 41 over the side across from it, 7.41, which we just solved for using the law of cosines. Well, we can get that 10 out of there by multiplying both sides by 10. And we can go from sine A to A by just doing the inverse sine. We can put that whole beast into the calculator, and we get about 62.30 degrees. Let's go back to our triangle and see if that makes sense based on the other side lengths. Okay, so we got something bigger than side B. But when we do triangle sum theorem and add those other two in, when I add 62.3 and 41, subtract that from 180, I get my third angle, 76.7. Now, angle C is definitely the biggest angle. Is it across from the biggest side? It is. And all those sides and angles match up. Okay, if there was something wrong there, we'd have to kind of go back and start over. That is how you use the law of cosines to solve for the missing side. You'll have another Pearson assignment this week. We are going to review the following week. We're going to have a test on Chapter 8 after that. And my gosh, we'll be just about ready for the final exam at that point. Okay, hang in there. The year is going to be over before you know it. Please, please, please shoot me an email at any time with anything that you need. Thank you so much. Take care, SHS.